Hi, my name is Barbara Maia. Welcome to Sciences News. In today's program, we will talk about two important projects of the Optics and Photonics Center, CEPOF. The first one is about how agro-photonics strengthens agriculture and agro-industry. Agro-photonics is a multidisciplinary branch of science that combines expertise in optics, electronics, semiconductors, materials, signal processing, communications, and more recently, biology, biophysics, agronomy, precision agriculture, and remote sensing. Agro-photonics propose a series of techniques and tools that allow agriculture to begin to harness and have a better use of energy from the sun, its temporal availability, its energy and spectral content, and to explore consequences and interesting synergies in the agro-industrial system present today. For this, photonic spectroscopy techniques such as nuclear magnetic resonance, infrared, LIBS, laser-induced plasma optical emission spectroscopy, fluorescence, and imaging techniques are used both for laboratory evaluation and system development for field application, as in aerial images, optical system robots, and sensors for water quality monitoring. Amid to the expansion and application of agro-photonics, the National Laboratory of Agro-Photonics, LANAF, was created in 2021 as part of the National System of Photonic Laboratories, CEPOF, and is one of the 9 multi-user laboratories of Embrapa through Brazil. LANAF's objective is to bring the private sector closer to researchers to discuss the solution of problems of interest, to work on projects with companies and startups along the lines of open innovation, and to encourage the creation of laboratory spin-offs in addition to training professionals who can work with the multidisciplinarity necessary in agro-photonics. LANAF was designed to act in the entire food production chain, from the analysis of input, agricultural activity, environmental sustainability, industrialization and/or commercialization, to delivery to the consumer, contributing to food safety and the safety of Brazilian food, seeking to increase consumer confidence and to open new international markets. That's why LANAF works with several lines of research, including input quality, monitoring environmental remediation and carbon sequestration in the soil, mapping of agriculture areas, and precision agriculture and post-harvest. Currently, this project, which is coordinated by Débora Marcondes Bastos Pereira, researcher associate to the Optics and Photonics Center, CEPOF, has 51 researchers, 6 postdoctoral fellows, and 6 science and technology institutions. CEPOF UFSCar researchers develop infrastructure to the production of essential inputs for several researchers. The project, led by researcher Professor Kleber Thiago de Oliveira, aims to produce 3 inputs: curcumin, ALA, and metiala. The infrastructure has chemical synthesis technology, which are fundamental part of the research area developed at the UFSCar, thus allowing the production of input aligned with environmental issues and at much lower price. For example, 1 gram of curcumin produced under the market standards costs an average of 2,000 Brazilian reals, whereas research spent about 100 reals to produce the same amount. The inputs produced are used in a series of socially relevant research, such as the use of curcumin in the creation of photolarvicide, a product that kills the larvae of mosquitoes which carry dengue, breakbone fever, and Zika virus, or in the creation of photosensitizing products that help fighting bacterial infections in long-term intubated patients. Metiala is used in drugs to fight skin cancer. Currently, the research is in the scaling phase. Its infrastructure works with the active addition of reagents, producing small amounts but at high frequency, which means slowly but at the constant pace, manufacturing kilograms of the mentioned inputs per month. The next step will analyze market demands for decision on increasing production or project expansion. Want to know more about science? So don't miss the next Sciences news.